Welcome to the world of Cisco Voice over IP as we start things off with Cisco IP telephony, the vision and certification. And let me start off by telling you how glad I am that you decided to jump into the Voice over IP program. I'm telling you, there's nothing like it. It's something completely new, fresh, and different in the IT industry. So what I want to start things off with is going through what networks look like today. Let's look at the current state of our networks and then why an organization would choose to use IP telephony. I mean, the PBX and key systems have worked for years. Why change it? Then, after we've answered that question and kind of gone through the manager list of all the cost savings benefits and new applications that are out there, we'll then take a look at what it takes to move to IP telephony. Starting with a phase one migration, which is where most organizations that already have an existing voice infrastructure, that'll probably be where they start. Then we'll look at a phase two migration and what that looks like as people turn in the old equipment and move to a complete data voice infrastructure. Finally, I want to talk about the Cisco certification for voice, the CCVP, one of Cisco's newest certification programs that focuses on nothing but the voice over IP technologies. Well, let's start things off by hopping into our helicopter and humming up to somewhere around 100,000 feet and looking down at the world of networks today. You see three major types of infrastructures that exist. You have the data network, where your PC plugs into the hub or the switch, and that connects to a router. And that could be in the workplace, or that could be connected to the internet, the largest data network in the world. You have servers and SQL and database and things of that nature. That's what we're most familiar with. You then move over here to TV, cable TV, recording standards, video cameras that record to a beta or VHS video cassette, or this new HD TV recording standard that has very expensive equipment. And then you move up here to this voice network and you run into things like our telephones that are ringing at our homes, our cell phone infrastructure, things like that that are all completely separate. Every single one of these networks are their own network. They have their own set of standards, their own set of equipment, and if you ever want to integrate anything between these two, it starts getting pretty pricey. For example, if you ever call into a bank and you say, hey, what's my balance? You hit, the number 2 keypad or whatever, and the bank says your current balance is 1,152 cents. And you go, oh wow, I have $11. So you tied in from the voice network and it had to communicate to the data network. Now it was easy for you, but on the back end, the bank had to purchase extremely expensive cards for their PBX system, and that you had to tie that into a specialized proprietary database that allows it to communicate and read back and forth between these two. So you have ways of doing it, but they're just not natively done. So it is very difficult to make these worlds talk, although it's currently happening a little bit. Finally, the voice network is being stretched to places it was never meant to go. I don't know if you're like me, but you may have had one of these experiences. You log onto your computer, start programs, dial-up networking, and all of a sudden it pops up on the screen, you've connected at 33.6 kilobits per second, and you go, and you have to disconnect and redial again because you're just not connecting as fast as you wanted to. You have to get that clean connection to get your 52 kilobits per second or something like that. Yeah, I know that's a little while ago before you may have switched to high-speed internet, but at the same time, we're stretching that voice network where it was never meant to go. It wasn't meant to stream that amount of data across the standard telephone copper line. So, with all that in a plan, we need to do something else. And that something is collapsing all of those networks into one. The walls have come down and all the standards have merged into a common network infrastructure. Data, voice, and video streamed across the common network platform, and that is our data network. The data network has the technology to be able to host all of that in one place. With all these networks merging into one, I jotted on there, insanely cool things are going to be possible. No more do we have to buy these expensive boards to integrate video, voice, and data together or have these proprietary standards. It's all going to be into almost an open source kind of configuration in the sense that all the protocols will be an open standard. All these different mediums will be able to communicate and life will be much better. You're going to start seeing amazing applications that we already are seeing amazing applications that nobody thought possible. I mean, if you think about it, the service providers have been doing this for 3 or 4, no, much more than that. 6, 7, 8 years now. I still remember it. It had to be about 8 years ago when we got the letter in the mail from our cable provider saying, just so you know, we've begun offering high-speed internet in your area. And my mind instantly went, wow, surfing the internet at more than modem speeds. I was amazed and mesmerized. And it wasn't too long afterwards that my telephone company sent me a letter in the mail and they said, you know what? We've begun offering cable TV. And I looked to my wife and I said, it's happening. She said, what? And I said, all the networks are becoming one. And, I had my arms in the air and she shook her head and walked away. And it's all these service providers are beginning to offer the same service. If you're with a cable network, they've begun offering cable TV and IP voice. Well, they don't call it IP voice, but they're running their own telephone lines to your house over an IP network. You have the telephone company now offering cable TV and voice and, of course, high-speed internet. So the service providers have begun doing this for a long time. It's now time for corporate America to follow suit and integrate this into their own networks. You're starting to see standards like H323, a standard like SIP, that defines all of these different infrastructures for the data, voice, and video networks. Point these right down here to these different traffic types for our new applications to comply to. I mean, when I was talking just a moment ago, when all these clouds were separate, they all had their separate protocols, their separate standards that they designed to. Now you'll have one standard that inside of, say, H323, you'll have protocols for data, protocols for voice, protocols for video, and ways to link them all together easily without buying these expensive boards. Speaking of expensive, let's focus on IP telephony itself, as in why an organization would use IP telephony. Well, there's first off some trackable cost savings, and these are things that you could write down on paper. You could create a formula, a spreadsheet, and it would say, here's how you save money. The number one saving cost that I can see is the moves, adds, and changes, and I'm talking immediate return on investment. Now, I know that may surprise a lot of you that are thinking, well, what about free long distance or something, one of those big cost savings things? I'll talk about that in a little bit. But moves, adds, and changes in the old world would require a specialized PBX technician or key system technician to come in and reprogram that device. I mean, you can't just unplug a phone from a PBX and plug it in at some other location, I'm talking within the company, and expect it to work at all, even a different port. You have to reconfigure each port for what phone number that represents. So on average, Cisco did some tracking, and this is verifiable information. On average, if you have a on-staff PBX person, you will be paying probably somewhere around $75 for each move, add, and change. And if you move, a whole floor from one floor to another, or a whole group around, that can be considerable. If you don't have a PBX person on staff, the cost jumps up to somewhere around $100 to $200 for each move, add, and change of a device. And that's hourly wages, contract income, whatever that may be. That adds up very quick because Macs, it's not MAC addresses, it's moves, adds, and changes. These happen all the time. You have reduced wiring, and this is primarily in new buildings, to where now we don't have to run two sets of cable, one for the voice and one for the data network. We can just run not only one set of cable, but one strand of cable per location. Each cubicle or office will only need one RJ45 Ethernet jack that the phone can connect to. You can daisy chain your computer from the phone. You then hit the reduced telecommuter and branch office expenses. You used to have to buy something known as tie lines if you wanted, say, a telecommuter or a branch office to integrate into that voice network. And those tie lines are a monthly recurring cost, and it got expensive. In this world, we can connect in with a VPN connection or shared data line that we already have for our existing data. So the cost really isn't all that much more than what we would pay typically to allow somebody to connect to the office from any remote location. Not to mention some of the whiz-bang, wow, that's cool stuff, like I've got a 4-digit extension at my house and people call me and they don't even know I'm at my house besides the dog barking in the background, because that, is tied into the voice network through a VPN. It's as if it was directly connected. You have the IT staff consolidation, and every time I start talking about that, I just go, because it's one of those things that nobody likes talking about except the management, because they know they can now do more with less. You now have one group of people that manages the voice and data network and video, to throw that in there, all with one group. Now that group does grow a little larger because the standard IT staff, if you just have a few people, sometimes can't keep up with everything they have to do. So hopefully not too many of us will have to go. We have the application consolidation. Instead of having separate systems, separate applications for the voice network and data network, those applications all become one. For example, take a hotel. In a hotel, they have an application structure that allows people to order room service from their phone, that to go on their TV and order a movie or something like that, to check in, check out, all of that. And you can consolidate that now into one database structure, into one application. You can, for instance, have a phone in somebody's room that allows them, on the little on-screen display on the phone, to order room service, to order a movie, to check into their room or check out when they're leaving. All of those have collapsed into one structure. And last and least, I like to say, is toll bypass, aka free long distance. The reason I put this last is just it's become one of those things that I'm just like, every time I hear it. People always say, "Oh, what do you get with voice over IP?" "Oh, free long distance, free long distance, free long." I've heard it everywhere. Everybody thinks voice over IP equals free long distance. And while that is absolutely true and can be pretty beneficial if maybe you're going to international locations, free long distance, I mean, long distance rates over the last 5 years have plummeted. Companies can get, a penny, 2 pennies, 3 pennies a minute for long distance. So if you come to their table and say, "Oh, I can get you free long distance to your branch offices," they're going to laugh at you. They're going to say, "Hey, we pay $100 a month for that, or $200 a month. Where's the real cost savings?" So the reason I put that last is not necessarily because, that'll be the last amount of money. It's just normal IT people just come to the table and that's all they have. They say, "Hey, we need to upgrade to voice over IP because free long distance is there." There's much, much bigger savings than just that. Where I start getting really excited is in the non-trackable savings. I call them soft cost savings. It's not really things you can figure out in an Excel spreadsheet because it's different for every company, but really these are things that will save you money in the long run. Number one is a single inbox for messages. This allows you to have kind of like the inbox. I need an echo after that, the inbox, box, that has all the voicemail, the fax, and email in a single location. Instead of you having to go, for instance, to a cell phone or to a voicemail system at your office and then check the fax machine and then check your email, you get them all in your inbox on your PC, and you can print them, you can respond to them, or so on. You can even pick up a phone if you wanted to do it that way, dial in and have the system read an email to you over the phone or read a fax. You just have one inbox that can be accessed from any application or device that's tied to the network. This is a fun one. Extension mobility saves office space because you can have phones that are not just assigned to one person. Here's the vision. I mean, you need to close your eyes for this one. Imagine yourself, keep your eyes closed, walking into an office, and you sit down at your desk and the phone is not yours. And you get a little freaked out. You go, did I just get let go? What's going on? My phone number is not on my phone. And the manager goes, "Oh, no. You're still employed. You just have to log into your phone." So you log in with the little passcode they give you, and poof, there's your extension. It appears. And then you log out and you walk over to another cubicle and log in there. And poof, your extension appears. And then you log out and then you fly to San Diego, which wasn't your original office. You're sitting there, you walk into an office, you log in, and poof, there's your extension. Your extension follows you from place to place. So you don't really have a phone that's yours. It's kind of like the roaming profile days of Windows, where you could log in and there's your desktop, and log in somewhere else and hey, my desktop followed me. Now it's the same things with phones. So the beauty of that is you no longer have to have phones dedicated to people. You can let people share phones or log into phones as they need them and log out when they don't. You have internet website integration, and I just tossed happy customers on there because people like the ability to talk to people. It's, ordering online for some people is just a nerve-wracking experience, and primarily non-technical people. To type in your credit card information into a form on a screen is kind of like, "Ugh," people kind of shy away from that. They'd much rather talk to a complete stranger over the phone and give it to them. That's much more comfortable. So now you can have an internet website where people click a little button on there and they talk to somebody over their PC. Nobody pays for long distance or anything like that because it's all voice over IP. So you get better customer support, better customer integration, things of that nature. Finally, and I think this is like fireworks should shoot out of this bullet, open architecture. I know it sounds not all that exciting, but from the PBX days, this is a major change. When you had PBX systems, if you bought, say, a Lucent PBX, you had to buy Lucent phones and Lucent cards and Lucent support and Lucent PBX people. It's all one system. And then if you changed over to Nortel or some other vendor of PBX, you had to buy Nortel phones. You couldn't use that Nortel phone with the Lucent system or vice versa. It's all different systems, different training, different structures, different protocols, different everything. With this new world, we're seeing standards-based protocols like SIP. This is the new almighty protocol everybody's talking about. The predecessor to SIP was H323. We're seeing MGCP emerge as a brand new standard that people are starting to love, especially service providers. And I'll talk about all these different standards, but these are going to be standards-based. I can already take a Cisco IP phone and load different images on it that allows it to work with different company structures. Not that I'd encourage you to do that, just because, of course, we know Cisco is the best. But we have, these Cisco phones that could move between companies. Or I could use a Cisco system to manage non-Cisco phones. It's all going to be an open architecture, and that's going to breed a lot of cool applications because not only Cisco or Avaya or all these other voice over IP companies can write applications for their systems, third parties can. Anybody can. It's like if you are a Linux person, you'll love voice over IP if you kind of get into that Linux buzz because Linux is all open source. Everybody's like, hey, anybody can write applications. It's fun for all and it's free. It's kind of like everybody loves free stuff. And that's going to be a lot of what we see for voice over IP is just applications that are very low cost because it's so open for anybody to do these programming and recording. The fun part is I haven't even begun to get started on the applications that are possible with voice over IP and some of the, wow, look at that. I call it whiz bang wow things that are just like, holy smoke. It'll blow you away, and I'll go through that as we go through this entire course. So here's how a company moves to voice over IP. I call this phase one of IP telephony. Initially, companies aren't just going to take a forklift, go into their IT room, and gut the entire voice infrastructure. They may have paid hundreds of thousands or millions of dollars for their existing PBX system. The initial move for a lot of companies is to keep the existing PBX system in digital phones. Those are the type of phones that work with PBXs. And what they'll do is they'll start integrating those devices, these PBXs over here, instead of going directly on a T1 line to the PSTN, because that was the old days. We would go into our PBX system right here. Let me grab my WAN link. And have a connection to the PSTN. And if you wanted to connect these, you'd buy tie lines and that kind of connection. And instead of that, we still, you can still keep your PSTN connection. We need those. But we now connect the PBX to the routers. And for inter-office calls, we start routing them across the data network. This requires minimal commitment, minimal purchase of voice over IP equipment. I've seen a lot of companies jump too far too fast, where they get excited about voice over IP and they just buy stuff and gut the old infrastructure and jump into the new. And sometimes they're not happy because they weren't prepared for such a big jump. In this case, you allow it to move very slowly. You have a few new routers that you purchase, a couple new interfaces to let these routers connect to the PBXs, and the nice major benefit that you get with this is you do get your free long distance between your offices. You can get rid of those monthly toll lines that you're buying, the monthly charges that you're paying, and now route it over the existing data infrastructure. Now, it's not just a lot of this is the misconception a lot of people have. When they think voice over IP, they say, "Oh, well, you're just taking calls from the PSTN and sending them across the WAN." Big deal. You have to upgrade the WAN bandwidth and so on, and so you're paying, virtually the same. Well, that's not really true because you can compress your voice over IP calls. Instead of taking the standard 64 kilobits per second that it takes when you send it to the PSTN, you can smush them down to where they take about, drum roll please, 12 kilobits per second and still sounds crystal clear in voice quality. So that's a major benefit that you get right there. The major requirement for this is quality of service, which is one of the courses that Cisco has in their voice program. I'll talk about that in a little bit. But if you try and send your PBX traffic across the data network without quality of service, ouch! Your voice calls will sound horrible, like a crackly cell phone conversation, if you have any congestion on your wide area network at all. So that's the number one thing to deploy is quality of service to prioritize that voice traffic everywhere. Phase one is a necessary step for most companies, but for IT people like me, it's kind of a bummer because once you do it, once you get the PBX going across the WAN, it's kind of like, oh, it's a little anticlimactic because people are still using the same phones they always used. It's still the same PBX system. There's no real new application. It's just you're getting free long distance. And the excitement kind of wears off after a while. So that's where phase two comes in. And this is the call manager structure where we upgrade to a full voice over IP network. This is where the voice and data network have truly become one network. You're running all voice. There's no digital or analog voice going through a PBX and having to be converted to voice over IP. It comes from the phone natively as voice over IP. So you go ahead and put your PBX and all your digital phones on sale on eBay with a buy it now price of $100 or so. Because so many companies are doing this, it's really driven down the price of PBX systems. So this allows the true integration between the voice and data networks to where you have the new stuff. Like I said, it's kind of anticlimactic after phase one because all you get is free long distance. Now you have true voice and data integration, and that's where you get all the benefits of things like extension mobility, of the new applications, of services on the phone, of surfing websites using a phone. So this is where all of those new infrastructures are going to take place. And I jotted on the last bullet, you can see there, typically new buildings or new structures start here. For example, Intel. I actually was speaking with a few people from Intel, and they have dictated, I'm out here in Phoenix, Arizona, and they dictated that all new fabrication plants that are built here in Arizona are all going to be voice over IP. And the reason why is they don't want to have that phase one setup. They don't want to build a building with old technology that they're going to be tearing out in a few years anyway. And that brings me to a huge point. It's very possible to integrate phase one and phase two structures without a problem. For example, let me grab my pen here. I have this router that's connected on the left-hand side of the screen to, one area. Oh, let me get a new layer to draw on here. So this router right here is, say, connected to Arizona. And then this router is connected over to California. Now, Arizona is maybe a new building over here, and California is a building that's 5 years old. This structure over here does not have to be phase two. I could still run the PBX and digital phones over here and slowly begin bringing up my network infrastructure as voice over IP in Arizona. And maybe later when we have the budget, then I can upgrade California. And that's what a lot of companies are doing. The new sites that they add will be voice over IP. The old sites will stay the same until they get the budget and the justification to do that upgrade. So it's very possible to integrate both of those structures together and have them interoperate, even in a single site. Say you have a single site of 1,000 people or so. What companies will do is they'll bring up, instead of a replacement network, a parallel network. They'll bring up voice over IP typically for us, the IT people. We get it first because we're the ones that are going to have to troubleshoot it if things go wrong. So we'll have, 3 phones out of the 500 that are IP phones, and then we'll slowly but surely department by department, person by person, office by office, begin moving people one at a time over to the new voice over IP system until finally you get to the point where there's 10 or so people left on the PBX and you make that jump, sell the old equipment, and now you're truly a native voice over IP network. So with all this new technology in place, you can imagine that Cisco has a new company strategy to manage it. They call it AVID, the architecture for voice, video, or integrated data. This has been around for about 6 years, but there's still a lot of confusion around it. I still get people asking me, is this an AVID router, or is this an AVID switch, or can you teach me a little bit about AVID? Well, if I taught you about AVID, it would probably take about 2 minutes because there's not much to it. Essentially, it's a new company strategy that Cisco has come out with to manage all of these structures coming into one. It's just a little mysterious because everybody thinks it's a technology. It's kind of like Microsoft's .NET. When Microsoft announced .NET, everybody said, "Oh, that must be a new, new platform, a new application, or something like that." Uh, I guess the difference is I'm still confused as to what .NET is. Avid, there is no confusion. It is allowing their routers and switches to manage all these new data types coming across a single infrastructure and developing new applications and new hardware and new devices that are capable of handling all this stuff. One of the things I've participated in for the last 5 years or so is all the networkers conferences that Cisco has at all these huge places. And every year, John Chambers gets up and says nearly the same thing. He comes up and says, "Hey, companies are collapsing their networks. They're all going with a single structure. This is our direction. This is where we're headed. This is Avid, the new structure that we're looking at, allowing all these devices to come into a single network. It's just their company strategy." Well, let me wrap up with something for all you certification junkies out there, a brand new certification. It is called the CCVP. And essentially, this is the structure that Cisco's certification program has started to take. You start off always with your CCNA. To be in this class, you need a CCNA or equivalent experience because we're going to start jumping into these routers. And I'm not going to get into enable mode, privilege mode, show run, things like that. That's all prerequisite information. Now, from that CCNA, they developed 4 programs. First off, the routing and switching track that most people go into. There's 4 additional exams. Put a little times 4 here from the CCNA, and you end up with your Cisco Certified Network Professional. And that's, 2 more exams, a written and a lab exam, and you get down to your CCIE routing and switching. Normally, people will follow this one first, and then they'll jump into one of these 2 other ones, or if they're maniacs, both. The CCSP is the security certification. Again, 4 exams over here to get your CCSP, and then they now have 2 exams, a lab and written exam for CCIE in security. Never been much for security as of yet. I know how to work it. I know how to set up PIX firewalls, but this I would say is my weak point in the certification track, just because it hasn't lit my bulb yet. I'm not too fanatical about it. This side I am a nut about. This is the brand new one, the latest and greatest, the Cisco Certified Voice Professional, which was much needed. They used to have all these specializations that people would get before, and finally they consolidated it all into a professional certification. Unfortunately, there's slave drivers over here. They have 5 exams to pass this, and you go from your CCNA, 5 exams to get your CCVP. So we get kind of nailed over here instead of having the 4. You start off, this is the beginning point, with this certification. There's a test that is called C-Voice. This used to test Cisco Voice over IP, Frame Relay, and ATM. That's why they decided to call it this. But now, Voice over Frame Relay and ATM have gone by the wayside. Not that it's not being done, but nobody uses those protocols. They all use IP. So C-Voice is the foundation for Voice over IP, aka what I call it is, I was writing aka, Voice Level 1. Tells you how to do the Level 1 deployment. Following that is CIPT, which is nothing but Voice Level 2. That's where the technology I just talked about, you're gotten rid of your PBX and so on, and replaced it all with a call manager infrastructure with the new phones and so on. Quality of service, of course, an essential one to be in there. That's a separate exam. IPTT is the IP telephony troubleshooting. And then the latest and greatest to be added is the gateway gatekeeper exam. This is specific functions talking about how to bridge the two networks together with the gateways, connecting to the PSTN and all the nuances there. And the main focus of this course is the sacred H323 gatekeeper, which is the, I guess you could call it the overlord of the network. And when you start getting a enormous voice over IP network, this is typically the last class, last test that people take because it integrates pretty much all this technology into a single course. That will get you your CCVP, and they weren't too mean here. They have 2 more exams, lab and written, to go after the CCIE voice. So all these together is their certification program. Now, one last thing before I go on. There is a new specialization that they've developed called IPTX, which is IP Telephony Express. I was showing you how to set up Call Manager, essentially a voice level 2 network, using nothing but routers and switches. That's a pretty cool technology because it even allows things like Unity, which is the voicemail, to be integrated into the router with something called Unity Express. As of right now, they have not added that to the CCVP because I'm sure there's just too much stuff to put in there. But for those of you interested in the IP Telephony Express, that is now known as a specialization rather than a professional certification that you can get. Well, I'm excited to get going into this track, and I hope you are too. But before we do, let's just recap and lay that foundation concrete that we're going to build on as we go throughout the rest of this course. First off, we talked about what networks look like today. 3 separate network infrastructures that we're working with, voice, video, and data, and it'd be nice to move them all together. And that is why an organization will move to IP telephony. By doing that, 1 set of staff, 1 infrastructure, lower cost overall on the system and management of it, and plus, all the whiz bang wow cool new features that are going to be coming out for it. We also looked at what it takes to move to IP telephony. A phase 1 migration being just taking the existing PBX structure and moving it onto the data network, still keeping the same phones, same infrastructure, just routing it across the WAN. A phase 2 migration means the PBX and digital phones are on their way out. They're making the move off the network, and we've replaced them with things like the Cisco Call Manager and IP phones that look something like that, without the jagged edges. We then have the Cisco certification for voice we talked about in all the certification programs, but this is going to be the voice professional that we see the 5 new exams for, and of course a new CCIE certification that has been released. I hope this has been informative for you, and I'd like to thank you for viewing.